Suppose we have a group of 7 students, and we want to choose 3 of them to form a committee. So the important point is that in this case, the order does not matter. And so what we mean by that is, for example, let's say that choosing Alice, Bob, and Carlos gives the same committee as choosing Bob, Carlos, and Alice. It's the same group of people. And so this is different from permutation because remember, for permutations, order matters, but for combinations, order do not matter. So let's count the number of 3-person committees here. And so let's see, imagine you have the 3 people. Now, in how many ways can you choose the first student? So let's think of it like this. Let's first choose them in order, and we're going to end up overcounting, and then we will divide by the overcounting to sort of get rid of it. So if we choose in order, for the first option, we have 7 students. After choosing 7 students, we now have 6 for the second option. And now after choosing 6, we have 5 for the third option. That's okay. So we have 7 times 6 times 5. But the issue, like we said, is that since order doesn't matter, we are overcounting here. So in what way are we overcounting? For each ordering that we do, so let's say we do Alice, Bob, and Carlos, we might end up choosing this. But if we chose Bob, Carlos, and Alice, these 2 count the same thing, but in our formula here, we're counting them as 2 distinct things. So then the question is, whenever you have 3, let's say, students here chosen, in how many different ways can you order them? But we know that is actually just the factorial. So in how many ways can we order 3 students? That's going to be 3 factorial. So this number here, we just need to divide it by 3 factorial. So the amount of ways that we can, order them. And so 7 times 6 times 5 divided by 3 factorial, if you compute this, this will be 35, and that's the answer to the question. So how many different committees are possible? 35. And so this kind of this kind of counting problem is called the combination. And so a combination is an unordered selection. And in general, the number of ways, so again, you can rewrite this using just like the factorials. And so in general, the number of ways of choosing R items from a set of n distinct items is given by this formula here. And we call that n choose R. So in our example, this here is going to be 7 choose 3, which by the formula, we saw this will be 7 factorial divided by 3 factorial times 4 factorial. Now, of course, the 7, you can write it in this, the 7 factorial, you can write it in this way. 3 factorial and 4 factorial. And so these 4 factorials cancel out, and you get exactly the formula that we found. So again, in general, the number of ways to choose an unordered group, also called a combination, of R items from a set of n distinct items is given by this here, which we read it as n choose R. This is also called the binomial coefficient. And it's given by n factorial divided by R factorial times n minus R factorial.